Now let's solve the following equation. This symbol means the greatest integer less or equal than some x. So when I say x, I mean the greatest integer less or equal than x. Okay? If I have this is the floor function. Okay? The value of 1.5. Okay? So I can graph it here. This is 1. This is 1.5. What's the greatest integer that's less or equal than 1.5? It's 1. Okay? So this one is always, let's call it n, it's always an integer that belongs to z, the set of integers. Remember that the z is, it's the negative numbers union the positive numbers, integers. Okay, so it's the symmetric with respect to 0 of n. So if you graph n on the here on this axis here, they're symmetric with respect to the origin. Okay, their union of this number is z. We will come back to this notion, but for now we just focus on the floor function. Okay, we're looking for the integer, the greatest integer that's less than or equal to x. Okay, for instance, what's this value here? Minus 3.7. Okay, so if we see a graph, this is minus 3, this is minus 4, this is minus 3.7. Okay, the greatest integer less or equal than this one is minus 4. It's always on the left of this number. Okay, think of this this function, the floor function, as the following. You are on this line here, and assuming that you have here, this is your x. Okay, when you look up here, you're gonna find a value that we're gonna call the salient function, or the salient value. When you look down, you're gonna find the floor value. Okay, and both of these ones have to be integers. Okay, so this is just a quick reminder of what we mean by this one. In books before 2005, I think, we have this notation. Okay, something like this. So it means the greatest integer less than or equal to x. Now we call it the floor function, because we have two new functions, the salient and one more function that we're going to use later. But for now, we're going to use this new notation here, and we're going to solve this equation here. Okay, so now let's see what we mean here. The definition of the floor function of any number x means that x, this one, is an integer. Okay, and therefore x, the value, is an integer, so we're going to call its value is n, and therefore it's going to be x is going to be bigger than n and less than n plus 1, where n is in z. Okay, and using the fact that this is the floor function, we can write x as x is bigger than the floor of x and less than the floor of x plus 1. This one will help us solve many questions and many problems. Okay, so for now, let's solve this one. This means what? This means that the floor function of 2x minus 3, when it's equal to 3, it means that 2x minus 3 is bigger. Okay, bigger than 3 and less than 3 plus 1, which is 4. Okay, remember, this is our x here. So this is our x is 2x minus 3, and this is the floor function, which is equal to 3. okay, because it's in Z. That's why we have this one. From here, think of this one as our big X, and this is the values in Z. In this case is 3 plus 1, which is 4, and 3. Now we add 3 to both sides, we get 7 less than or equal to X less than 6 less than 7. Sorry. And dividing by 2, we get X is between 3 and 7 over 2. This means that X is between 3 and 3.5. And these are the solutions. The X is real, okay? So the solution in this case, it's an interval, 3, 3.5. 3.5 is not included. This is my set of solutions. So we don't get an X, we get a interval in this case. Using these facts here and working it out and using algebra, we can find the solution. Okay, remember all these ideas. We're gonna need them later.